Welcome to the Walton Pi. Today we're going to be talking about what it means for something to be a coset. So let's let G be a group. We're going to say that N is a subgroup of G, and we can denote that it's a subgroup by saying N is less than or equal to G. When we're talking about groups, that's the common notation to say it's a subgroup. And then let little g be an element of our group. We say that G big N is the set of elements G times N, where N is an element of our subgroup big N. We are going to say that that is a left coset of N and G. That specific set, that's what we mean by a left coset. And that any of the elements in Gn are going to be called representatives of the left coset. They are elements in it, so those are all representatives of it. We can also have a right coset where we just switch which order the multiplication comes. So if little g is on the right of big N, it's a right coset. And any of these elements are going to be representatives of the right coset. Now, we were writing these in multiplicative form, so if we have a multiplicative group, it's little g times big N or big N times little g. If it's an additive group instead, we are going to denote the cosets g plus n or n plus g, respectively. So where g plus n is the set of g plus little n's, where little n is in big N, and n plus g is the set of little n plus g's, where little n is in big N. That's just what the different notations are, but all of them are these specific sets. So let's look at some examples of cosets in a specific group. So here we're going to be looking in the additive group of all rational numbers. So we're going to denote that Q. A subgroup of Q is the group of all integers, which is denoted Z. And so since Q is an abelian group, A plus Z is Z plus A, because A plus anything is the same as that thing plus A. So we are going to just write all of them in terms of A plus Z's. So if we find any left cosets, it's also going to be a right coset. So let's look at some cosets. We have 0 plus Z, which is the set containing -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. That is one such coset. Another coset is 1/5 plus Z. So that's going to be all the elements that look like -3.8, -2.8, -1.8, -0.8, 0.2, 1.2, 2.2, 3.2, and so on. All of these are in that coset. All of these are representatives of that coset. And so here are two different cosets in the additive group of all rational numbers. Now the set pi plus z is not going to be a coset because it's not even a subset of Q. Pi plus 0, that's just pi, that's not a rational number, so that is not going to be in, so it's not going to be in Q, so that means that pi plus z can't be a subset of Q, so it's not going to even be a valid coset. I hope this was helpful in understanding cosets. They're a little bit tricky, so just play around with them for a little while and see if you can be able to figure those out. But I hope this video was helpful. Please leave in the comment section down below any other topics you would like to see me make videos on. And as always, I hope you have a great rest of your day and good luck with all of your math.